folks, today we are going to do the lab number 9 simple pendulum. The simple pendulum is a very important device. It's a very simple and very important device. Okay, and that's why we study today. The simple pendulum was used for as an element of a timekeeping device, and it was a huge revolution when we start using the pendulum in a timekeeping device. Okay, that's what you have to know about the simple pendulum is that the period, its period of motion, its period of moving from one place and back to the initial position. Okay, so here's an illustration of the simple pendulum. It's a string and a mass attached to a string. You can displace this device from the vertical and let it oscillate back and forth. Okay, so the period for the pendulum is given by 2 pi square root of the length of the string, divided by the acceleration of gravity. So let's go ahead and look here at the link of the simulation. Okay, the link is not working, so we have to copy that link and paste right in here. Here you go. Fat interactive simulation. Here you go. We're going to spend some time. We're going to look at this one first. So there are those options, right? Here you go. Let's take a look at the other ones. You have this one as well. We're going to use the introductory one. Here's the pendulum. You can displace it from the vertical. You can even measure the angle that you're releasing the pendulum from the vertical. You have a ruler here that you can measure the lengths of the pendulum. We have a stopwatch. We have a period trace as well of the pendulum. You can set up the different lengths for the pendulum right here in this sliding scale. Okay, 1 meter to 1/10 of a meter. You can change the mass of the pendulum as well. You can even change the gravity, but we're going to stick to the acceleration of gravity. And if you want to put some friction here, you can also do, but let's leave that in none for now. Let's take the pendulum from the position of equilibrium and let's get it to oscillate. Right here I'm giving an amplitude of 20 degrees, okay? And here you go. That's how the pendulum works. I'm going to turn off the trace, the period trace, okay? If you want to slow down the oscillation of the pendulum, you can do that. Here you go. And the watch also slows down, okay? So here you go. It slows down by quite a large amount of time. Okay, that's 1 second right now. So you can, it seems that they have slowed down by 10 times. So let's find out. Here you go. 2 seconds right now, right? 1000, 1001, 1002, 1003, 1004, 1005, 1006. Okay, this pendulum has been slowed down by 6 times. So 1 second here in this simulation corresponds to 6 seconds in real life. Okay, so let's stop. And I'm going to stop the pendulum as well. And let's go back to the handout. Okay, so we are going to keep that. If you make the pendulum frictionless, the pendulum will lose no energy whatsoever. The energy is going to stay constant, okay? So using a 1 kilogram pendulum, we have to change the mass of the pendulum to 1 kilogram. Let's do that. Here you go. 1 kilogram pendulum. We have 0.7, 0.8, 0.9. Here you go. 1 kilogram. Adjust using a 1 kilogram pendulum for each trial. Adjust the length of the pendulum. Displace it for 30 degrees. Okay, here you go. I'm going to displace it for 30 degrees. And by the way, I'm going to pause it initially. Displace it 20, 30 degrees. Here you go. I'm not going to release that yet. And release it to determine the period. I did some, by the way, I did some editing here in the original handout. Whatever is in bold face in red color, it was my correction. And whatever is in black, is a double strike, it's what was originally in the handout that's not appropriate to be there, okay? So those are my corrections. So here you go. Well, I need you to come up with a table. You can do this table in Excel. Mass, length, period, and gravity. Let's take a look at the table. I have a table here for you in Excel. And I'm gonna get a pre-prepared table for you. Let's look for it. Let me see if it's here. Projectile motion. Okay, it's not here, and